Welcome to CodeMash. If this is your first day. Otherwise, thank you for continuing to be at CodeMash. So today we're going to talk about unbreakable code. And to start off, let's look at what's a good example, someone who can write unbreakable code. And in my mind, there's no one better than Steve Wozniak. Even if you didn't know who he was, you could tell he's a pretty big deal because he has a picture of himself on his own t-shirt. But really, I like to think of him as the guy at Apple who actually builds things. So he's built the Apple II, he built the game Breakthrough. He's built a lot of really amazing things. But I didn't quite really grasp what an amazing developer he was until I read this quote. Woz designed all the hardware and all the circuit boards and all the software that went into the Apple II. Not one bug has ever been found. The circuit design of the Apple II is widely considered to be astonishingly beautiful and as close to perfection as one can get in engineering. And the things that really jump out at me is that we spend a lot of time trying to make things good, make things that don't have bugs. But those ideas are really tied to ideas of perfection and ideas of beauty. And when you're shooting for one, you're probably going to miss. Because if all you're trying to do is make unbreakable code, then you'll push out things without trying to make it good, without trying to make it solid. They're really all tied together. And the idea that these are all tied together is not a new concept. To make something unbreakable is really about having principles of craftsmanship, which the best definition of that I've ever seen is doing something good for its own sake. You do it not because you want it to work, but because that's the right way to do things. And I like that definition so much because it encompasses a wide range of things, including really intricate hand-carved wood features like this that took years of effort and practice. But it also involves incredibly simple things like furniture, like simple chairs that the design is really simple, but the execution is so perfect. These chairs, for example, are shaker furniture. They're almost 200 years old and they still work. Now that's pretty impressive. I don't think anything I've ever made will last 200 years. But they make chairs out of wood, materials that degrade that last 200 years. They're featured in museums. But they're simple things. So I'm Joe Morgan. I'm on Twitter at JoeSMorgan. And I live in Lawrence, Kansas. So if you guys are ever in Kansas City area, hit me up. I'll buy you some barbecue. I work at a place called DEG. And I got a couple of crazy kids running around. And so this one's 6 months old, which means last night was the first time I got to sleep for 8 hours, which is pretty nice. I'm also an author. I have a book coming out in about a week. But all that aside, I'm just a guy who writes code. And more importantly, I try and get a little better every day. So what we're going to do is we're going to look at the stages of craftsmanship and how each of us can use these ideas and these principles to get better at whatever we want to do. And the first stage of craftsmanship is the apprentice level. So the apprentice level is usually characterized by you have a lot of enthusiasm but not a lot of knowledge. If you've ever worked with interns, I like this picture because it's like they're running around with scissors. You don't want them to hurt themselves or others, but they're really excited to get going. And so at this point, the most important thing you can do is give guidance or seek guidance if you're beginning. The next stage is the journeyman stage. Probably most of us in this room are in this at some point. And at this point, you're just trying to gain more experience and more intuition. And we'll talk about what experience and intuition mean, because they actually have slightly different meanings. And then finally is the master stage. And this is when you fully internalize whatever it is you're working on to the point that it's effortless. It just flows out of you. And at this point, you can do really creative things. So most of the people who have names of programmers who've authored big open source projects are masters of some sort. So how does this relate to software? Most of my examples have been wood carving and things like that. But I think it's really interesting. So if you were to take the number of developers and then kind of map it along the different phases, I think it would look something like this. And this is based off of zero evidence. This is just my own gut. But you have like this jump of people who are apprentices, then it kind of drops a little bit. Then you have a whole bunch of people in the journeyman phase, and then really not a lot of masters. And I think the reason is because at the apprentice phase, you're really focused on getting something to work. And if you think it works, then you get this impression that it's good. And so there's a little bit of a drop-off because a lot of people are like, it works, that means it's good. And then they stop doing whatever they're doing and go on to something else. But after you work on things a little bit, you get this feeling that there's a better way to do things. And that's when you really start to seek out and you start to refine your craft to come to conferences like this. And so this is the journeyman phase. And so most of us are here because it takes, it's kind of a steep jump because it's kind of easy to learn a lot of principles. You can get pretty decent pretty quick. And then it levels off because at one point it gets really hard to push and get better and better. And I think this phase, though, is really nice because this is where we all get paid. So this is like the money stage, because once someone else will pay you to do a job, then you're pretty much out of the apprentice phase. You can quit your job, you can go somewhere else and make money. The final phase is masters, and there's very few people here. And the reason is because to do something well to the master level, you really have to love what you're doing. And I think there's an inherent conflict between being a master of a craft and working in the industry. Because if you remember, things were working back in the apprentice phase. You could sell the product, you can get paid. Business end doesn't really like master programmers. They act like they do, but they really don't. Because those guys want to do things over and over and get it just right and just perfect. Another way to look at it, I think, is even more revealing, is how each of us kind of map onto the phase. I asked before if you're a web developer, and even if you're not, I'm sure you can make some divisions. Everything we do, there's kind of divisions in what we do. So I'm a web developer. So there's server and infrastructure, there's server-side code, and there's front-end code. And me personally, I can get a server running, but I would never hire me to run your servers unless you plan on getting hacked a lot, I guess. But server-side code, I'm pretty good, but I'm certainly not at the master's level. And front-end code, that's where I'm starting to, kind of push the bounds of what I know. I know it really well. I usually talk on it. This time I'm not talking on it, but that's normally what I talk about when I go places. But everyone's a little different. I've worked with people who are really good at servers, masters of server-side code, don't really care about CSS, haven't looked at it in years, so they're a little lower. So just because you've been doing this for 20 years, you're probably still an apprentice in something, and that's okay. That just means you haven't put the effort in to progress. And if you look at all the different frameworks, all the different paradigms, it's really hard to get really good at anything. That's, I think, the other reason there are so few master developers, because it's really easy to tack on a new framework than it is to take what you know and push it a little higher to go further. Okay, so that's all aside. How do we actually get better? I think there's 3 big areas that you can improve in each of these levels. And that is your eye, which is what you read, what you see, how you interpret code that you take in. Your hand, which is what you actually built, what you compose, what you check into repos. And then your mind, which is the theoretical knowledge. Why is something work? Why is it good? Why is this a pattern and not something else? So let's dive a little deeper. The eye is, I think, the one that's the most neglected, but I think it's actually probably the most important. And here's why. I was reading this article, and as you can see, it was about 12 years ago, so it really stuck with me. And it was in the New York Times. And they hired a master furniture builder to evaluate a lot of furniture from IKEA, from Walmart, and just see how good it was from a craftsmanship point of view. And as you might guess, he was walking around, and the furniture was whatever. It wasn't done very well. But the part that stuck with me is at one point, he looked down, saw a piece of chipping paint, and said, this chipping paint could be an example of machine cutting without sharp blades, it looks like they painted before they actually cut the piece. So let that sink in. He looked down and he saw a piece of paint, and he could tell you something about the tools that built it and something about the process. The more you master something, the more you see the world differently than others. You probably had a time where you've been sitting with a family member and a website or a piece of software breaks, and immediately you start wondering, like, maybe there's a data issue, or I wonder if they didn't do this or that. No one else sees it that way. And so it builds on it. I was recently building some IKEA furniture for my kids, and I saw a piece of chipping paint. And what do you think I thought? Hey, they must have painted this piece before they actually cut it. It starts to transform the more you take in. And this has huge implications for development. Because some people here just see some PHP code. And if you don't know PHP, that top level thing, what it's doing is it's pulling a query from the query string. But a person who has mastered security and knows a lot about this can immediately look at this code and tell that there's a probable, anyone? SQL injection. And having someone who can just at a glance see a SQL injection, that'll save your company millions of dollars. That's how important the eye is. And going back to the original thing, there's also important to make things look good. There is the connection between beauty and having quality work. If you see a piece of code and it looks ugly, you don't really want to work on it. We all complain about other people's code and how it looks like garbage. And the reason is, I think, because it's hard to parse things, it's hard to work on things that just aesthetically don't look very nice. All right, moving on. The hand, and this is what we normally associate with craft. This is how you compose code. And I don't have any fun examples. Really, it's one of those things where you know it where you see it. This is a piece of code called Redux Thunk. And if you don't know anything about JavaScript, you could still probably look at this code and say, I bet the person who did this knows what they were doing. One of the things I mentioned early on was perfection. And perfection is kind of a hard term. But really, it's one of those things where nothing more can be added and nothing more can be taken away. And that's kind of the impression I get when I look at this piece of code. So you can see it's doing specific things, like they're using higher order functions, they're destructuring variables. But more to the point, it's well composed in the sense that everything has a very specific action and nothing is wasted. All right, the last area is the mind. And this one I actually think is the most overrated. And part of the reason is because programming kind of came through the academic route. It was first a field of math and logic, and slowly became a university course. So the theoretical foundations kind of get more emphasis than I think they're due, because at the end of the day, for those of us who are working programmers, it's what we make that matters. But still, you see like a lot of crazy crap on coding exams where they ask you algorithms that you haven't seen in years. And I think the reason people like the mind so much is because this looks like something that you can test someone on. So I don't know if you've ever seen this question. I've gotten this twice on coding exams. FizzBuzz. Yeah, okay, apparently some other people have seen it. So write a function that prints the numbers 1 through 20, print fizz for multiples of 3 and buzz for multiples of 5, and FizzBuzz for multiples of 3 and 5. And the answer is, of course, simple and really just testing to know if someone understands the modulus. And all I look at this is I think, who cares? Who cares if someone knows how to do this? It means that they did a Google search for common interview questions before they walked in. I've stopped asking these type of questions when I interview people. Instead, what I usually do is I open up a piece of code and I say, tell me what's happening there. And then, they should be able to tell me there's some functions doing this, that, and the other thing. But I really want someone who could look at this code and say, hey, I think you have a SQL injection there. That tells me that they've internalized and they've mastered a lot. So here's the roadmap. We have each of these 3 areas that you can improve, and we're going to go through each of the 3 stages and look at how we can apply those and get better. All right, starting off, the apprentice stage. When you're first at the apprentice stage, the thing you can do to improve your eye is to understand style. And why is this important? Style is how you start to communicate with the developers. And there was a test where they took some programming statements and had them all jumbled up. And they started off with the statements in the correct order, and an expert could memorize it better than a novice. But then when they jumbled it up, the ability to discern which was better, the ability to remember fell apart. So style is how you start to communicate. And it really hit me about 2 or 3 months ago when some people from our marketing department called me down. They said, hey, Joe, we have this piece of JavaScript code that we're trying to put on our Google Tag Manager, and it's just not working. Can you tell us what's wrong? And I look at the code, and it was about twice as long, and I felt dizzy. I said, I can't read this. I have to put it in a text editor. And it wasn't even the regular expression. It was all the crazy indentations, because I don't know if you can see the for line has a for and an if statement in it. It's just impossible to read. After putting in a text editor and getting some nice indentation, all of a sudden it looks better. So you probably, if you've ever worked with a new developer intern, you may have seen something like this, where they get a piece of code, and they do a bunch of stuff, and it works, but it just doesn't look right. They have multiple variable declarations. The curly braces are all over the place. Sometimes they use them, sometimes they don't. And the absolutely worst part about this code is that it works. If you were to execute this code, you would get the result you want. But no one will want to work on it because it's hard to read. So when you're starting off, and this isn't, again, this isn't if you're new, if you've been doing something forever, but you're in a different framework, a different programming language, start by cultivating a sense of dissatisfaction and knowing that there's ways that things could be better. So you should look at this and say, it works, but what can I do to make it better? And the best way is to learn community standards. Almost every language has some form of community standards linting rules. JavaScript has like 3 or 4. PHP has one that everyone follows. I'm sure every language has one or the other. Learning those community standards is the first step to making you start to look like a professional. And the best way to get this, aside from memorizing standards, is just to read code. Whenever I move into a new framework, the first thing I do is go on GitHub and look up as many examples as I can find of actual live code that have been built by someone, because that will give me an idea and intuition for what a good-looking project in this framework or language looks like. And of course, you should set up a linter to kind of keep you honest. Linters will run through your code and tell you when you're not following the standards that you set for yourself, and that's a good way to kind of have some machine help you. So if we were to run this code through a linter, it's the exact same code, but now it looks really clean. It looks really nice. This looks to me like something that someone actually put the effort in to get right. It's not perfect. There's some optimizations you could add in there, but it's readable. And when you're starting off on anything, having readable code is really important, because the next step is getting feedback. So getting feedback is really important when you're starting off in anything. And let me tell you an example of what feedback looks like. Everyone thinks that feedback has to be something complicated, where you pull everyone into a conference room and you go through a big project, or that the feedback you give has to be really detailed and take a lot of work. When I first started off, I had been programming for maybe a few months, and this is a PHP project again, and I was told to add a new property and a new method to this class. And I had no idea what I was doing, so I fumbled around, I looked up a bunch of stuff, and after messing with it, I learned that if you put this weird word static in front of something, and you put this weird word static in front of a function, then if you use these strange dots, I got the answer I wanted, so it works. I was really proud of myself. I cleaned it up, turned it in for a code review, and one of the senior developers came up to me and he said, "Hey Joe, why is this static?" And all I could say was, "I have no idea." So code reviews are important because they teach you to be deliberate. I wasn't deliberate when I put it in. I got it working, but I didn't know why. And feedback doesn't have to be complicated. Asking questions is way more important than telling someone something's wrong. I turned in something else another time, and it wasn't following any of the linting rules. It was kind of jumbled. I had just slopped it together and tossed it in. And the developer who was working with me on the project took one look at it, and he said, "Do it again. Come back to me tomorrow." It doesn't have to be complicated. So this is a message to people as reviewers. If you're reviewing code, you're not being nice when you withhold feedback. You're really preventing someone from being better. So it's a two-step process. You have to ask for feedback, and you have to have someone who's willing to give honest feedback. So what do you do if there is no way to get feedback? And this happens a lot. In this case, the best thing you can do is write tests. In testing, I think a lot of people consider a more advanced, like an intermediate topic. But I really think it's something that you should do as soon as you can on any framework or project or language or whatever. So here's an example of a piece of code. And if you don't know JavaScript, what this is doing is it's fetching some data from an API, parsing the data, and then doing some things with it. And it doesn't look overly complicated. It matches all the style guidelines. But if you start to write a test for this, you find out it's really complicated. You have asynchronous functions, you have multiple conditionals, you have all these methods that you're going to have to stub or mock out. Tests are a good way to tell you that your code is being overly complicated. It's kind of like a canary in the mine shaft, because if you start to testing and things are hard, then that's a clue that it needs to get better. And every test and every assertion you write is a statement for why code exists. So if you can't write a test for it, it probably shouldn't be in the code base, because you're saying this has to be in there to solve a very specific problem. And if it's hard to test, make the code easier to test. It's okay to rewrite code that's working to make it easier to test. All right, so the mind. When you're first starting off in anything, this isn't as important as you think. In Shakespeare, the top 10 most frequently occurring words make up 21% of all words, whereas the top 100 words make up 54% of all words. It's far more important to grasp the basics when you're doing something, because those will come up over and over again. It's way more important to understand a few things really, really well than to have a huge catalog of things that you don't quite understand. So when you're beginning, just get the basics down, get things working, and most importantly, learn by reading and doing. When I wrote out that poor class that had static methods in it, what do you think the first thing I did after getting that feedback was? I went and looked up what static methods were, and found out when they're actually important and what to use them for. The feedback is how you're supposed to be learning. Don't go out and buy a bunch of books and stack them up next to your bedside. You're better off just taking the feedback you give and using that as an example of where you need to go next. Well, I already went over that. OK. But there is one kind of big area that I think is important when you're starting off on anything, which is learning the relationship between parts. So when I first started there, I had a mentor who said, tell me everything that happens in a website from the minute you hit enter in the address bar till the second the spinner stops spinning. So I was like, okay, and this is very crude. It hits a DNS server, which translates it to a server, which hits up a web server, an Nginx and Apache config, which points you to the server-side code, which routes it to a view, which renders the DOM, and then the JavaScript and CSS come in. And the reason it's important to understand the whole and the relationship between parts when you're starting is because lots of things go wrong when you first start working in something new. And the more you can kind of understand the big pieces, the easier it is to understand where you need to look. So if I can tell that the page rendered, I didn't get an error, but nothing's showing up, then I can know that the top half of this little chart here isn't the culprit. Whereas if nothing loads, then I can guess maybe it's something with the server or the Apache server. And this can go in different areas. So whenever I try and fail to get better at understanding Linux, the first thing I do is I understand all the root level files and what they're for. So this way, when I'm starting to try and figure out where a config file is or where log files are, I can already eliminate certain possibilities. You don't need to know in depth, just kind of having a vague idea. All right, so that's the Apprentice. Next, we're moving into the journeyman level. At this point, the next step is to make code beautiful, which is kind of a squishy term again. But I like that better than the negative thing, which is a lot of people complain about ugly code or smelly code. And making code beautiful is the positive way to phrase that. So here's a piece of code. I don't know about you, but in my mind, this is pretty ugly. Look, there's tons and tons of parameters. There's this temple of doom in the middle of it. There's all sorts of crazy stuff. It's really hard to parse. But this piece of code would actually pass most linters because it's following the rules. It's still somehow ugly. So when you read it, you kind of get this icky feeling, this feeling that something is just bad. It's kind of a gut feeling. It's hard to put your finger on. And we have a name for this, which is smelly code, which I like because, when you smell something bad, you just respond. When you see code that's bad, you just kind of cringe. And over the years, people have come up with a lot of names for different code smells. You have long parameter lists, and you have complex conditional blocks, different return statement, uncommutative name, magic numbers, magic variables, things like that. And if you want a good list of it, I think Coding Horror, if you do a search for Coding Horror and code smells, he has a really good list of code smells. But way more important than that is don't memorize it. A smell is a feeling. And having a list that you memorize is kind of nice when you're starting off. But more to the point, if you see something and it just feels ugly, then go with it. That's a sign you need to refactor, particularly if it's your own code. And so it's all about trusting yourself. When Wozniak was making his Apple II, he wasn't thinking about how other people would perceive the circuit design. He was making it to fit what he thought would look good. And as a result, it turned out well. So trust that feeling. If you feel that ugly feeling when you're looking through code, sign you need to refactor. Conversely, going back to this, when you see good code, you kind of get that pleasant feeling, And there's been times, and you've probably had it too, where you write a piece of code that's particularly nice, and you kind of just sit back and bask in the glory of it for a second. And I don't think there's anything wrong with that. We should be happy that we make something so nice and elegant. And especially if we see something in the wild, if we see code that someone else has written, it's a good idea to kind of keep some of these in our pocket to remind us what the goal is. What are we going for? Finally, there's a little bit of beauty in logic. There's this interesting study they did where they took mathematicians, they put them in an MRI machine, and they had them read a proof that many people consider to be a beautiful proof. And when they did that, they found that the same centers that light up in people's head when they look at scenes of sunsets and beautiful landscapes, those same centers light up when mathematicians read these proofs. So it's not, there is something there. It's hard, not everyone gets it, but there is something nice. All right, on to the more practical part. At this stage, when you're at the journeyman level, the most important thing you can do is build an intuition and learn how to refactor. So, pop quiz. Joel on Software says when he gets coding exams, he does two things. One, he gives a really technical question that requires in-depth knowledge. But the other thing he does is he gives about 4 or 5 simple questions that everyone should know the answer to. And the reason he gives these simple questions is not because he wants to see if they get the right answer, but he wants to see how fast they get the answer. Because the quicker you can get the answer, the more it shows how the intuition you have. So here are the questions. Just give you a sec to see if you can think of what you would answer. Get an array of unique items, determine if a string starts with an uppercase letter, and calculate the area of a circle given a radius. Okay, so how many people are pretty confident they could get all three? It's pretty good. So let's look at the first one. Getting a unique string. So this is a really crude way to answer this problem. You take an array of items, you start with a blank array, you loop through the array of items. If an item is not in the unique array, you add it to the unique array, and eventually you return it. So this is something that will probably take a little longer to write, and shows that you can answer the problem, but you don't have like a strong intuition for how it works. And this is where refactoring comes in, because I think a lot of more experienced programmers spend more time refactoring their own code than they do writing in the first place. First you get it working, and then you refine it until it's something right. So if I wrote some code like this, and I actually have been asked this question on code exams at least once, first thing you do is you want to know that there's a better way to do things. And then the other secret is you can look up solved problems. So Stack Overflow is not just if you don't know what you're doing, it's also if you have an answer but you want to make it better. So you could rewrite this using an array reducer, and it cuts that code down from, I don't know, what was it, about 12 or 15 lines to about 3 lines. Now you could argue this is a little harder to read. I don't know. I think it's easier. But it's definitely simpler. There's less involved. You can get more code on a screen. But even this isn't as simple as it can get. You can keep iterating over ideas till you get one you like. So in JavaScript, you can get this down to a single line using the set operator and then these 3 weird dots, which we'll get into in just a second. So iterating over ideas and refining them down is an important part of A, learning how to refactor, and B, building that intuition so you have more and more tools in your tool set for when you encounter problems. And again, most important thing is to have a test, because once you have it working, you want to make sure you don't break it in the process of refactoring it. All right, so how do you improve what you know? This is a big area when you're a journeyman. And the way I like to divide it is into tools, principles, and patterns. So when you're working with tools, and by tools I mean syntax or just whatever, syntax frameworks, anything you use to build something, the most important thing is to understand why things exist. Because syntax was all developed by humans. That's the nice thing about programming. Everything was developed by a person with a specific goal or a specific reason that it went in there. And so recently in JavaScript, these 3 dots came out, and they're what's called the spread operator. And what they do is they take an array and turn it into a list of items. And when I first saw this, I thought, I have no idea why this is in there. It doesn't make any sense. It's a little confusing. Plus, we have all these methods for working with arrays. So if you wanted to add an item to an array, you would use the push method, which many languages have. You have a new item on your array. It's no big deal. But then after I spent some time reading other people's code and looking through it, I realized that every language solves problems in their own way. And if you want to master the language, you have to understand how to solve the problem in that specific language, because this may be a little different. So this may be the way to solve the problem in PHP or Ruby, but is it the JavaScript way to solve the problem? Well, not really. And the reason is because this causes mutations, which in JavaScript there's been a recent turn to a more functional language, so mutations are bad. You can cause some problems later on in the code. So what the spread operator did is it allows you to tack on items to a new array by taking the old array, spreading it out, and putting a new item on. Your original array stays intact, and you have your new array with the same item. And once you realize that it's there to solve these specific problems, then all of a sudden you can see it everywhere, starting to solve different problems. It makes copying things easier, it makes combining things easier, and you can convert objects to different types using these 3 dots. So understanding that syntax was added to solve very specific problems will help you understand when to use it and how to use it better. And this isn't just for languages. I think one of the problems when you get to a certain level is that when you switch languages, you kind of take all the baggage of your main language with you. And so I'm a JavaScript developer, and there's been times I've worked with people, and they've shown me code, and I've looked at it and I said, "Are you a .NET developer?" And they'll say, "Yeah, how do you know?" I'm like, "I don't know. This is just .NET code, but with JavaScript language." And this happened to me recently when I was working on Python. So how many people here are Python developers that have worked with Python? Just a handful. So Python is a little strange because they have multiple classes per file. And in PHP, Ruby, Java, lots of places, the rule is one class per file. So I opened up a file and I saw this and I was about ready to refactor it because I thought they didn't know what they were doing. And then I thought, maybe I'm the person who's wrong here. And it turns out I wasn't the only one who's confused. 870,000 people were also confused by this. But the Python way to solve the problem is to use modules, and having multiple classes per file is no different than having multiple functions per file. So understanding the framework, the language that you're in, and trying as much as you can to not bring your baggage from the other thing is a real challenge. The next thing is to learn principles. And so this is when you can go to Amazon and buy all those books. But the important thing is when you're learning principles, they should really solidify what you're building. We're people who make things first. That's what we do. So everything we learn should be in the service of making things better. Here's an example of that. Rebecca Murphy on the book JavaScript Patterns wrote, this was the book that showed me there were names for so many patterns that I discovered purely through fumbling around on my own. She had enough of a base that when she had this book, it starts to give her names and starts to fill in the gaps for things she didn't know. Because all these principles are really just there to help us communicate. And they are important. If I said I was building a factory, people would know instantly what I was making. They would know that I would return a new instance of an object with certain thing set, versus if I said I was building a singleton. They help us communicate, but they should really only be there to help you when you get to the point that you're able to use them. Because experience without theory is blind, but theory without experience is mere intellectual play. So if it's not being internalized into what you build, it's not really helping you. You might as well just go read a comic book or something. So the way to do this is to run everything that you read through your hands or your eyes. And here's a couple examples. David, who is the creator of Ruby on Rails, wrote, before I created Rails, I redrew many of the diagrams in Omnigaffle for Martin Fowler because I liked the book so much. He took the book, he internalized it, and he created something new with the information. On another book on refactoring, he wrote, the trick to reading this book is to carefully read through every single refactoring pattern and then apply it to your own code base. You don't have to commit things. You just can't blow through the book or you won't learn anything. You have to take each pattern and try and apply it and internalize it. That's about building that intuition. So once you're ready to do this, who cares what book you get? If you want to learn algorithms, learn algorithms. If you want to learn language paradigms like mutations, side effects, or patterns, that's all good. The most important thing is that you somehow internalize it and build it into what you do on a daily basis. And always spend some time reading open source code because this is living code. It shows you what everyone does. And GitHub is full of examples of code developed by amazing people that you can go and you can skim through and you can see what really great code looks like. All right, so moving into the master level. And this is where things get interesting because at this point, they've really internalized everything they know about a language, framework, paradigm, whatever. So at the I level, what they're starting to do is they're starting to see abstractions across projects. So here's an example. There's Dan Abramoff, who's the creator of Redux. He once wrote about a pattern he called the presentation and container components. And this became like this huge holy war in the React community, and people were saying this wasn't a presentation or this wasn't a container. And he said, I don't know why everyone's so upset. This wasn't something I invented. It was merely something I noticed. It was just something he saw in multiple places and kind of pulled out as an idea to help guide future development. In the famous Gang of Four books, they say, we have included only designs that have been applied more than once in different systems. Most have never been documented before. They're closer to naturalists who go through different code bases and see things over and over, and are able to abstract what's the core principle? What are we really trying to solve with this pattern? And only then do they create the pattern and solidify it in the book. And the way they say to do this is follow that feeling of deja vu. If you feel like you've been doing something over and over, that's a clue that you could start to pull out a pattern and maybe share with other people. And seeing abstractions is something that actually progresses almost perfectly along the same line. So when you're first learning, one of the first things you learn in coding is don't repeat yourself. And so most people who are beginning to code, they have these functions in a file that do the same thing a couple times, and that's good. And once you get to the next level, that's when you start to see reusability across a project. And so they start to pull out code into the architecture of the system so it can be reused across components and across different classes. But once you get to the master's level, that's when you're able to abstract things so well that you can see how it'll work across any project, not just your project, but any project. And that's a really hard thing to do. And so the way that they're able to do that is they're able to write code that's highly reusable. So how do you write reusable code? First off, don't jump into it too early. I like Martin Fowler's rule, which is first time you do something, you just do it. Second time you do it, you wince at the duplication, but you do it anyway. And the third time is when you refactor. So let's look at just one example of how you can make reusable code. And I think there's a talk sometime today on writing reusable code that I'm sure goes into much more depth than I am able to in a few minutes. As always, first off, start with a test. So here's a piece of code that is highly coupled to a very specific API. It hits an API, it gets the data, and it returns a string containing the information. You couldn't reuse this code anywhere. It's so tightly tied to a very specific API endpoint that it's pretty much useless. So the way you would notice this is if you were trying to write a test, that whole part that starts with knock, blah, 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 what that's doing is that's hijacking an AJAX request and then returning whatever you tell it to return. And so this is, I think, one of the instances where people think writing tests is hard because you have to have all these third-party code. That's not hard code to, well, that's a hard test to write, but that's really a clue that your code is bad and should be refactored to be easier. So one of the first steps to refactoring is pull out as much specific information as you can. So you pull out that API endpoint into its own function, and now you're using a function which will give you a certain piece of information which you will then manipulate. So this is a little more reusable because you can change the API endpoint. You can pass in, maybe you can inject it. You could pass in different parameters. You can change where it's pointing. Maybe it's going to a database. Maybe it's pulling a static config file. But testing it is still a little difficult because since it exists in the function itself, you have to, at some point, mock it out in your test. You have to hijack what it's doing and instead say, what do you want it to return to make it testable? So highly reusable code has as much injected into it as you can. In this code, you're injecting both the method to get the data and the specific piece of information you want. All this code is doing is one thing, which is manipulating the return data into a string. So now that you're injecting it, fetch information could be anything. It could be an API fetch. It could be a database call. It could be a static file. It could be user input. It doesn't matter what it is. As long as it returns information, it works. This is really easy to test because then in your test, all you have to do is write out a function and pass it in. Super simple. No outside libraries needed. Test, test, test. I think that's the last time I say it. All right. Finally, the most interesting thing that master programmers do is they creatively apply ideas. So the thing they have to do first is they really have to master their own language. So what happens is they master it and internalize the language so much that they can easily see the gaps and the holes that they need to fill. Going back to Redux as an example, this project came about because Dan Abramov wanted to speak at a JavaScript conference in Europe. And he had to come up with a project to show off. And so he saw that there was this language called Elm, and it had a certain architectural framework, and he just took it out and applied it to React. So here's the Elm architecture. Here is the Redux architecture. He saw that there was a gap, and he took what he knew from another language to fill in the gap. JavaScript was the same way. It was created by Brandon Ike, and he wanted to use the language scheme into a scripting language. Netscape partnered with Sun Systems. They said, OK, your language also has to be like Java. And so as a result, he had to take multiple paradigms and put them together. So he could see the different gaps, and he could see the different needs, and he pulled from each language to create what he wanted. And here's my absolute favorite. Linus Torvald wanted to try out a new computer chip he bought. He bought this chip, and he didn't have any operating systems that could utilize the features of the chip very well. So he set out to write his own, and he posted, this is an actual message he posted on a message board. Hey, I'm doing a free operating system, just a hobby, won't be big and professional like GNU. This has been brewing since April and is starting to get ready. I like any feedback on things people like, dislike in Minix, as my OS resembles it somewhat. Same physical layout of the file system. He had mastered operating system design so much to the point that he could take what he needed, and build something that he thought was just going to be a hobby and ends up running most of the web. So what connects all these? Well, there's not really a connection. Creativity happens because they're bored, because they're curious about how something works, or sometimes just because they were told they had to do something to continue their employment. But in every case, they understood their inspirational material well enough. That's what a master does. They know their thing so well that they can fill in the gaps with something new. All right, so here's the wrap-up slide. Here is all the different levels and all the different ways you can improve. And it doesn't really matter where you're at. As long as you're doing one of these things, you'll be getting better. So one thing we didn't really talk about was why. Why should you focus on craftsmanship? And I'm going to end with this image. This is a ritual called the Sand Mandala in Tibetan Buddhism. And what they do is they create a representation of the universe using colored sand. And I like it because it's a little like programming. Everything we do, it feels like you're just putting tiny little pieces of sand into a much bigger project. And it's really easy to think that it won't matter, to just kind of toss it on there. And if you do that, you'll step back and you won't have anything. You'll just have a big pile of sand. But if you put everything down deliberately, if you write everything with precision and perfection, you'll step back and you have something amazing. And the last part of this ritual is they sweep it away, which I think is another, relates to programming, because no one really sees what we do. Our customers see the end product, but they don't see the process. And so it can be easy to think it doesn't matter, but that'll come through eventually. So focusing on just doing things right, doing things for their own sake, is satisfying in its own way. Okay, so that's all I have. Again, my name is Joe Morgan. Let's see, I got a book coming out on the 10th, so there's a discount code if you want that. Otherwise, I'm on Twitter, and it's my website, and don't forget to rate this talk. If you have any questions, just come up and see me. Thanks.